Hi, welcome to this week's session on the microbit. This week we shall be looking at communicating between microbits. This is going to build up on all the stuff we've covered so far and add on a new communication system too. So first of all, let's ask the question, why might we want microbits to communicate with each other? Well, there's a couple of possible things, and you can probably think of a couple straight away. There's a couple of different scenarios where we may want more than one microbit and we might want them to talk to each other. For example, last week we were all creating those virtual pets. Maybe you'd want to get a second microbit that you could use with a different virtual pet on, and maybe you might want them to talk to each other and react in each other's presence. Or maybe if you had a second microbit, you could make it into a feeding controller or a remote control for your pet. Even put games on it that you can play with your pet and send information to the pet microbit. You could also use them similarly as remote controls. I think I briefly touched on that. This is basically using one microbit to send commands to another microbit. So you could use it like you would with a remote control car or with the remote control on your TV. You're sending commands to one of the microbits. You could do this so you could have extra buttons because you've run out of buttons on the first one, having more buttons on the second one with different things on them. Brilliant. It gives you a larger range of activities you can do. Or you may just want to be able to control one microbit with another one. As I said, like a remote control car, you could have one driving the other. Another example is you might want them to share data. This is something we're going to cover a bit more in a few weeks' time. We're going to be looking at sending data from one microbit to another. So, for example, if you're using them in an experiment, you wanted to send temperature data or sound data or acceleration data from a microbit being used in an experiment to the one plugged into the computer that's producing the graph. Also, the last one is detecting each other, detecting another microbit. So being able to detect that you're near another microbit, being able to react to the presence of that microbit. And if you look here, I've also got able to locate a beacon. You can set up a microbit as what is called a beacon, where it can just broadcast a message on a loop, and you have another microbit trying to read that message or locate that message and trying to find it and zoom in on it and approach it. So that's a few examples or a few scenarios where using more than one microbit and having them talk to each other would be really helpful. But the next question is how do we do this? How do the microbits communicate with each other? Now, the version 2s have two options. They have both radio and Bluetooth, and the version 1 just simply has radio signals. This is what we're going to use. Even though we're using version 2s, we're going to use radio signals because there's more channels available, so we don't interfere with each other's microbits when we're doing this. It would be great if you could remote control something for you, but if you're on the same channel, on the same frequency, same signal as someone else is controlling theirs, you're going to interfere with each other and you'll find yourself controlling someone else's. So how do we actually program it to react to radio signals? Now, for this, what I'm going to do is I'm going to take you through, like we did last week's video, I'm going to take you through how to produce a program. In this case, if you're producing it on your own, this is the best place to go because you're programming two microbits at the same time. So this is the URL, this is the web address that you would need to use. It's the same as your standard one. It's in makecode.microbit.org, but we add on a /3 multi. So that's -- multi. And what this will do is this will load up a slightly different screen to what you're used to seeing. I'm going to show it now. It will load up this screen. So this is what you see. It's a double screen. It's a split screen. It's the home page for the MakeCode, but if you notice, you've got two separate ones on the same page. So what we can do is, in this side, I'm going to set up the transmitter. What is a transmitter? That is the program that's the microbit that's going to send information. And then on this side, we can set up a receiver. And what does that mean? That means it's the microbit that's going to receive the information and act on it. So you see here, I've got two different screens with my block programs. If you notice, the simulator's vanished from the left. It's actually come down here. Don't worry, we can make it bigger when we want it, and we can use it in a bit. So let me just quickly demonstrate something. First of all, as I was saying, you want to make sure but they're not going to interfere with other radio signals or from other people. So first of all, we need to set them into a radio group. Now they need to be in the same one, so they're listening to each other. And we need to select a random number that hopefully no one else has selected. So we've got here a whole range, like the sound and the light. The range is anything between 0 and 255. Don't ask why. I think Microbit just likes those numbers. So I'm going to put my two into the same radio group so they can hear each other. I'm putting it in group 25. I'm hoping no one else has picked that number. And now I'm going to start getting them to talk to each other. So now they're both on the same channel. I'm going to also set this up so I know which is which. I'm going to call this one send. Yeah, because this is our transmitter, it's sending information. And I'm going to set this one as receive, because that's the one receiving the information. So I now know what the program is that's running on each of these microbits. Now, what we can do is we need to be able to send this information. So how do we send information via radio to the other microbits? There are two ways. We actually have a whole radio section here. You can send a value, a number, or you can send a string. If you remember, a number is anything from 0 to, I think this one can go up to 99,999. A string is a line of symbols, numbers, letters. It can be just one letter, it could be a sentence, it could be a word. So this is what we can do, is we can either send a message or we can send a number. Now, the easiest thing and the quickest thing is to send things in numbers. So if we grab a radio send number, we can send any number between, as I say, I think, let's just see how high it can go. Oh, it can actually go even higher than I thought. There we go. It can go quite a long way then. We don't want to send a number that big. Let's just stick to the numbers 1 to 5 to start with. Let us have the transmitter sending a signal whenever we press button A. So when we press button A on our transmitter, on the one sending the information, it will send the number 1 via the radio connection to the receiver. Now, at the moment, this isn't going to do anything because we haven't told it to. So what we're going to do here is we're going to go to those radio blocks. And because we're sending numbers, we want this one. On radio received number. So it's going to be listening now for when it receives a number. Now, the only number we want to listen for at the moment is number 1. So we use our favorite if statements from last week. So if, here we go, if, and we go back into there and we get the equals, receive number. So we drag that from there. If you notice, we don't actually have the variable receive number available to us here or here. So instead, we can just drag it out of that box and it'll give us a copy of it. So if the receive number is equal to 1, which is what this one's going to send when we press A, we want something to happen. So we could just put in a reaction. Just make it so it smiles when it receives something. Fantastic. So we can now test this to see how well this works. We can make these bigger. See here, we've got launch in full screen. That's going to take up that side. That one's going to take up this side. So we've got the transmitter, we've got the receiver. So if we then press refresh to see it, so that one, send, that one, receive. Perfect. Let that run through. So we know that when we press this button A here, it's going to send a signal, and this one smiles. There we go. Perfect. So if we press A here, nothing happens on this one because this one's not sending information. This one's just receiving. This one's sending. So let's go back, shrink those back down. Let's say we wanted it to do more. Let's say we wanted that waiting screen. Now, there was one problem we had last week, and I think we've all seen this problem now, is that when we start to put an animation in for the forever loop, it was starting to interfere with input. So let's see, I don't know if this is going to interfere. Let's find out. It probably will do if we put in, we grab some more of these. And let's just have it do bigger grin. So it's doing, actually, let's just have a go. Smile, straight face, smile. So we've got a little animation here, and we've got an animation here. If we make these big now and run the program again, wait for it to run through the on start block first and get to that waiting animation. There we go. So I've got a waiting animation now. When I press A, if you notice, we've got that interference again where those 3 dots appeared halfway through. Now, there is a way we can deal with this, and this is something we couldn't show you until you knew how to use your if statements. So, and your variables. So what we're going to do is we're going to make it so these two don't interfere with each other, because at the moment it's working as if that is over the top of that, and that is showing through in the gaps between these blocks. So how can we do that? Well, to start with, let's take this animation out of here. And what we will do instead is we will introduce a variable. So we need to make a new variable, make a variable, and we're going to call it input. Okay. So as we've made a new variable, as we always do, we put it set to 0 in the very on start loop to set that variable exists, and then it's to start at the value of 0. What we're going to do is when it receives the number 1, we're going to have it so it sets that input to number 1. Brilliant. So we've now got a variable that's got value 1 when it receives the number 1 by radio. So in the forever loop, we're going to put a new if statement. We are going to put an if in here. Take that out, put that underneath. So I've got an empty if statement. And what we need is an equals. So we grab the comparison and we put the variable input. If input equals 1, we want it to show that animation, that little animation that we put together in here is now in here. Then we want to say if it's not, so else, we want it to do that waiting animation. So let's see what that's done, what changes that's made to our program. So let's load it back up, get it all restarted. Because I've made changes to this program, it's got to restart itself. There we go. So it's now waiting. We press button A, it smiles, and there we go, we've got the animation. If you notice, there's no waiting dots anymore, it's not interfering, but also notice it's not getting out of that loop because we've not told it to change the value back again afterwards. What I mean by that is we've said that as soon as it receives that number 1, it changes the input to 1. And this is going, if the input is 1, I'm doing this animation. What we need to do is turn this off after a little while, or else you're not going to be able to do, pressing A is not going to repeat it again because it just acts like button A is constantly pressed down. So what we're going to do is we're going to put a wait. We've got the pause. So we're going to pause it for, let's say 2 seconds, 2 whole seconds, which is 2000 milliseconds. And then we're going to make the variable back to 0. What this means is we press A on the transmitter, it will send the number 1, as shown here. When we press A, it will send the number 1. This will receive the number 1. As soon as it receives the number 1, it will change our box. It will put the value 1 into our input box, into that variable. And that will stay there for 2 seconds. And then we'll take the 1 back out of that box and put it back to 0. What this means in the forever loop is that it will only equal 1 for 2 seconds. And then it should go back to our waiting animation. Let's have a look and see. Wait for the program to boot back up again. Wait for it to go back to the waiting dots. Brilliant, we've got waiting dots again. Press the A button on the transmitter. There we go. So now when we press A, it reacts. And then it returns back to waiting for a new bit of input. Let's shrink these both back down. So what if we want it to do more than one thing? Well, let's get another input. If we put this in here and put when button B is pressed, we would like it to send a different number. Let's say number 2. Brilliant. So we now have something happening, a different number being sent when we press button B. So now we need to tell this what to do when it receives button B's number, which is number 2. So we've got this here. If the received number equals 1, it does this. What we can do is an else. So if it receives that, it does that. Else doesn't let us put in a value. So what we need to do instead is get an else if. So this else if here gives us that ability to put a new one of these in. So we can actually copy this. I'm going to use Control C and then Control V. And there we go, I've copied it. But I'm going to then change that to number 2. So now, if the received number is equal to 2, what we need to do with this then is have a different input number. So we want to change that input variable again. So what we're going to do is we're going to copy this very similarly into here. So let me see, we want to set the variable, but we want to set it to 2. We want to pause the variable for 2 seconds again. So it stays as 2 for those 2 seconds. We then want to put it back to 0. Okay. But we now have this empty else. Now an empty else just means it won't do anything if these 2 aren't true. But it's always nice to have this because we can actually put in here an error code. So if something's gone wrong and it receives a number that isn't one of these 2 numbers, it will error code for us and it needs to tell us it's errored. So we just use the show string because it's a word we want it to show us. Error. So if it receives a number, because this is only on when it receives a number, but it's not 1 and it's not 2, it will show an error. Now, what do we want it to do when it receives the number 2 and where do we put it? Well, we've already got an if statement, if else. If we press that plus again, we get that else if. If we copy that, we can then tell it what we want it to do. So let's see, what would we want it to do? Let's go for, actually, you know what? Let's go for the beating heart, which just uses 2 icons, big heart, little heart. There we go. So let's double check the program. Here we go. Let's get it restarted. There we go. Refresh that one just to make sure. Here we go. So I haven't got any animation on this one, so I don't know when it's ready or not. So we might want to put an animation on there. So if I press A, we know we should get that smiley face animation. Okay, and then back to waiting. If we press B, we get the nice beating heart. There we go. So now we're sending 2 different messages to it. We can make it so it lasts longer for the animations. We can change how long the wait time is before it resets the variable back to 0. So you can take, I think we can take it up to 5 seconds quite easily. But it depends on how quickly you want it to be able to react to a new input. So that is the basics for how we can communicate between one microbit and another to send messages. What about sending data? Well, as I said, the sending data is something we'll be covering, I think, a couple of weeks' time. We'll be looking at how to send data for experiments, for science use, to make graphs. So we'll leave that one for today. But what about the beacons? What about being able to locate another microbit? Well, let us go back to the home page. I'm going to start a new project. I'm going to call it, I'm going to call this the beacon. So this is the one sending out the information. And I'm going to call this one the detector, because that's the one that's going to detect this beacon or this other microbit. So as we're using radio again, we need to set them both to the same group. So they're both listing in the same radio group. Oops, can't do it from that side, got to do it from this side. There we go. Let's choose a different number. Let's go for 30 this time. Okay, there we go. Right. So this one is going to be a beacon. So it's going to continually send a signal. We'll do, so we'll get radio, we'll get it. Okay, so we're just going to have it send a number like we did with the previous one. So we've got radio, send number, but we've put it in the forever loop, so it will continually send a number. I don't know, let's choose the number 5. There we go. So we're going to continually send the number 5. Right. We could have it so it sends a string to identify it. We could have it so it sends a number, just sending something from here. Now this here, what we want to do is we want to detect how far away an object is almost, how close we are to it. We want to, it's like a metal detector, but it's more of a beacon detector. So what we can do here is we want it to, on radio received, there we go, we would like it to look at the signal strength. So here we go, we've got something here which is signal strength. So the signal will be stronger the closer you are to the beacon. But we want the detector to tell us how close we are to the beacon. Now, if you think about how a metal detector works, if you've ever seen one of those working, you put it over something and you scan, and if it detects something close, it starts beeping. So maybe that's a good idea. Let's use sound. So what we could do is we could have it, let's see, ringtone. Now, the reason we're going to select the ringtone is this is just a constant tone, just a dee. And at the moment it's set to middle C, but instead of that, we can set it to the signal strength it's receiving. But the problem is if we go and have a look at our thing here, the signal strength goes between minus 42, minus 128. So for some reason, they decided to use different numbers for the signal strength to anything else. Everything else has been between 0 and 255, not the signal strength. That's between minus 42 and minus 128. So the best way to make this work is if you have a look at our tones, if I quickly pull out a spare one of those ringtone ones, you see here we have the notes. And if you select them, it actually has a value. Now, musical notes are between 831 and 988. So what we need to do to make it so we can hear the difference and make it so it equals the same as notes, because at the moment, if this was minus 42 or minus anything, it doesn't have a note that it will play. So a way to solve this is we can make a sum out of it. Let me get them back. It's a mass block. So we're getting a mass block. We put it inside there. We put the mass block in there. There we go. So now I've got the ringtone. It's the signal strength times 0. Well, that's still not going to help because that's just going to make it all 0 because anything multiplied by 0 is 0. Instead, we're going to multiply it by minus 3. That way, it's always going to be equal to a note. So if I just stop that a moment, if we load up these now, let me demonstrate what's happening now. Now, you won't be able to hear this because I haven't got the volume shared. Let me see if I can change that. So here we go. The sound is now shared as well. So you should be able to hear this program as it runs. Now, because we've got it doing sound, it has made a little sort of audio jack there. So now if I play this program, you can hear we've got that hum. Now up here is the signal strength. You've heard that. I can adjust it by sliding over. So this is the highest note. So you can have it so it can detect how close a beacon it is, how close it is to a beacon, like a metal detector. Okay. I'm now going to make that be quiet. I can find my mute button. There we go. So that's no longer making any noise for you. I'm going to turn off the noise so it's not sharing sound anymore for you either. So that is how we can set up a basic detector for a beacon. You can do quite a lot with that. You could have it so that your microbit is detecting how strong a signal is, whether it's moving closer to a beacon, whether it's moving further away, which will have some importance later on. Now, there is one other thing I'd like to show you in this session, and that is that we can't do this split screen in the microbit classroom setting. In the microbit classroom, we don't have the option of having two microbits being programmed at the same time. We're going to have to do something slightly different, which is have them share the same program. This means that both microbits that you'll be using will have the same program on them. Both will be able to send, both will be able to receive. So I'm going to quickly just draw up a little program here that does the smiley face animation when we press button A on one of the microbits. It'll make the other microbit do the smiley face animation. So here we go. First of all, we need to set, because we're using radio, the very first thing you need to do is set a group. You'll need to make sure that no one else is using the same one. So you might need to let people know which one you're using during the classroom session. It doesn't matter in the classroom, online, but it will do on challenge day if we are using radio signals. You want to be on a different frequency to anyone else. So pick a random number, pick a number between 0 and 255. Play around, just skit it around and let go. Oh, I'm going to be on 173 today. The chances are then you won't be on the same channel as anyone else. So I've got my radio set to group number 173. I want my forever loop. Fantastic. In my forever loop, I'm going to want one of those if-else statements. The else is going to be my waiting animation. If it's not got anything else, it will do the waiting animation. Perfect. Okay. Now we go back into logic and we get one of those equal blocks and we go. And we get that block out, the on radio received string. Brilliant. We're getting the program together. Hopefully you'll recognize this from the one we did just a few minutes ago. So on radio received, perfect. We need an if in there as well. And we need the logic in there too. There we go. So if, and we drag that receive string, equals 1. We'll go back to the channel 1. We then create that variable. Mine's still saved here, thankfully. I've got my input variable. So we set the input variable to 1. I've realized I've used the wrong block. Don't know if any of you noticed that. There we go. If you noticed it put that little error symbol, if I just put that back, because I've used the wrong block, I know that because see here, I have, let's see if we can zoom in a bit to show you. There's this little error triangle to tell me there's a problem. The reason there's a problem is it's looking for a string and then I've asked it to match it to a number and it can't do that. So I've made a mistake, but the program has told me I have. So let's zoom back out again. So let's get the right block. Received number. Let's get the if statement. Let's get that equal to comparison. So if and drag received number equals 1. Brilliant. That's now working. I've got rid of that error triangle. We want that variable. As I said, we want to set, we haven't put it in the on start. We need to set it to 0 in the on start because it's a new variable. And then we want to set it to 1. We then want to pause it. So that's in the basics. We go to pause. Let's pause it for 2 seconds before we make it set the variable back to 0. There we go. Now, while that's running, we need to make sure this matches. So input, if input equals 1, what do we want the program to do if the input is 1? Well, I'm just going to do what we did earlier, which is going to put in a little animation here, which is this, the straight face to the smile face. Slightly the other way around to earlier, but it will do the same sort of animation without interference from this. But if you notice, at the moment, we've only copied the receiving program. We also need to include, because we're having the same program on both the transmitter and the receiver, we then need to include the send. So we need to say on button A pressed, we want to send number 1. So we have both programs now in here, but on one microbit. So now if we go over here, if you've noticed the simulator's changed slightly, we've got a play button over it. Well, that's different. Well, let's see what happens when we press play. Okay, so there's nothing different at the moment. We've got it waiting. What we need to do is just quickly tap that. Oh, we now have 2. There we go. We now have 2 microbits. So if I press A on the bottom microbit, we get the smiley face animation appear on the top microbit. But because the same program is on both of them, if we press A on the top microbit, bottom microbit gives us the smiley face. Okay, I hope that gets you all started on having a look at communicating between microbits, having a look at how to get them to talk to each other. And we look forward to seeing you in the next session. Okay, thank you.